This video is brought to you by Sporlan, quality, integrity, and tradition. It is time to change this unit out. So it's in bad shape. It's been needed to be changed for a while. It's a 2004 unit, 6 ton. So we've got power turned off. We're gonna get going on this right now and get it all disconnected. We've got a crane and an AC showing up, so it's gonna be a fun one. We gotta be careful because there's ice all over the roof right here because we had water running as a misting device because this thing had completely, it was an issue. Blockage in the condenser, restriction, just a bunch of problems. So we had water running on it and that all froze this morning because it's chilly out. But we got the unit all disconnected. We're just waiting for the crane to boom up and get his cables over here. We're gonna hook on, we got tag lines. Everything's disconnected for now. We'll clean it all up once we get the new unit up here. All right, we got the new unit set. So at this point, we just start taking all the panels off, getting everything ready. We gotta mount. First things that we mount is the disconnect switch and the drain line because they'll need air conditioning before they need heating. We're not gonna need heating today. So we're gonna get all that stuff mounted, the economizer put together, and then we'll start working on everything else. A lot of these units, they run wires to like smoke detectors and zone sensors down through the return duct. And they were coming up through the economizer, which made it really difficult to get the economizer assembly out for service reasons. So when we're installing the new one, we put the economizer in, I marked the edge of the economizer and I drilled a hole through the base, put a strain relief connector there. So now thermostat wires are safe, out of the way. You can easily pull the economizer out as long as you just disconnect the plug. We're getting there, just doing some thermostat wiring. So here's the deal. There was some stuff going on in this unit that I'm not 100% sure. I have a general idea as to what was happening, but they were passing through one thermostat wire hooked up to nothing. It's running through the unit. It was going through the compressor section. So we rerouted it all into here, zip tied up, 2 stat wires running over, coming down into here, and then dropping down into the deck. So one of the stat wires was, well, 2 of them are running into the smoke detector, which is right on the other side of that wall. So they're running right in there. And one of them, I think, was a test and reset station because it's going all the way through. And then the other one was a red and white wire. I believe that's what disconnects the unit, although it was unhooked up here. So all that we're gonna do is we're gonna hook that guy up to this right here. That's this number 1. And then we're also gonna hook up my 2 zone sensor wires right there, coming from the thermostat downstairs using this. And then we're gonna get the meter out and check continuity. It's either breaking or making a circuit. And that'll kind of determine how I'm gonna wire it into the circuit board. So we just need to get out a meter and tone out the red and the white wires on this brown jacketed guy. They're sitting right here, right there. I need to tone them out, see what they're doing, make sure they don't have voltage or anything. They should just be an open or a closed contact, and we'll find out right now. All right, economizer's put back in, wired in. Not a huge fan of where it's located, but yeah, I'm not gonna redo everything. Everything's zip tied where it should be. We always leave the accessory plug for the economizer in case someone needs to disconnect it. So these things come with this jumper plug. You always wrap it around there when you put your stuff together. That'll go there. We're wrapping up the gas line right now and we're gonna go move on. All right, we are probed up on this guy. Got everything all set up. So now we're gonna go ahead and turn it on, set the blower speed, and then check everything else as we're going through the rest of the unit. We're currently setting up the Siemens controller. So we're testing it right now. So we did a full call for the damper to open. You can see that it's opening. So we know that's good. So now that we've done that, we're pretty much confirmed on our setup, and it's gonna save everything, and then it's gonna go into full cooling right now. So it took a few minutes. We gotta use the Wi-Fi stick because trying to set this controller up without the Wi-Fi stick is just stupid. Just trust me on that one. It's ridiculous. So we're just waiting for this guy to start up, and then we'll do a full profile on measure quick. All right, it's difficult setting this blower speed because this one has the axial vane motor, right? So you check the VDC, you check the static pressure, you adjust the pointometer right here and the dip switch. We're running really high static on this unit. We need to come back and clean supply and return. We're at 1.5 and we should be maxed out. 1.2 should be our total external static, but Yeah, it's difficult. I'm trying to get it lower, so I'm gonna adjust it lower. But if you look, if we go into our toolbox and we look at our static pressure, we have 1 inch. Wait, why do we have a net? Something's wrong. I gotta check my settings because something's wrong. We shouldn't be in a negative on the supply. We should be in the positive. So something's mixed up. That should definitely be positive. All right, yeah, I had something going on. So I'm turning it up, maxing it out at the max static that it can handle for that. So we'll get it at 1.2 and we should 2400 CFMs. Setting these things is always messed up, especially when you have issues. So let's see where our airflow currently is at 2200 CFMs. Temperature split looks decent. Delivering a little less capacity, but it looks like it's coming up. Yeah, this guy's looking good. Superheat doesn't look bad. Subcooling doesn't look bad. We're gonna let it run for a little bit and kind of stabilize out, but all those numbers look good. Approach, return air temp is 69 degrees, so we're freezing them out. So we're not gonna be able to run this very long. We got the gas line also done and piped. We had to use a couple couplings, but that's fine. We're gonna clean that up and then we'll spray paint it. The drain line, we were able to use the existing trap, which is in perfect condition. So we'll just paint that for him. And then, yeah, we're looking really good on this guy. This guy's doing everything it can. Economizer's pulling minimum outside air like it should be. Everything's good on that. This unit's looking really good. So it's a matter of just clean up, touch up, gas line. Still got to set gas pressure and stuff for the heater, but we'll get to that. Without overloading the motor, this is the highest airflow I can get on this unit. We've got total external static right at 1.2. My VDC is 8.53. You would basically set the dip switch and adjust the pointometer. So I turned it down, getting my static to 1.2, which is the max that the blower chart gives me. And it's saying at 2400 CFMs, or it'll deliver 2400 CFMs at 1.2 inches of static when it has 9.6 VDC. But we're at 1.2 inches of static and we can't get to 9.6 VDC because we can't turn it any higher because I don't want to overload the motor. So it's just one of those things. So if we look in here, I did fix the smart probe. It was out of whack. So supply is at 0.53. The return is at 0.68. So our return is really the problem. We probably got a dirty return grill. That's not part of this install and startup. So we can bring that to their attention and try to correct that later and adjust the static pressure accordingly. But for now, this is as good as it's getting. Vitals look good, 73 degrees outside. Everything's looking cool. So something that I did do is I put a couple extra probes on here. Okay, so discharge pressure on this unit out of the discharge line is 307 PSI. The liquid pressure, which is what we're using for subcooling, is 286. So there is a pressure drop across the condenser coil. So keep that in mind. All right, I don't have a combustion analyzer. Okay, so what we've got is we've got the unit fired into heat. We've got return and supply temperatures, and we've got 3.63 inches of water column of gas pressure on the outlet. They're calling for 3.5. So what I'm gonna do is I'm gonna adjust it down to 3.5 and see what that does to our discharge air. Without a combustion analyzer, the only thing I can do is look at my discharge air, make sure it's getting hot enough, and make sure my gas pressure is where it's supposed to be. There's not much more adjusting on this thing. So we're right at 3.51 inches of water column, and we're gonna give it some time for the temperature differential to climb. So it is gonna be a little skewed because we have the panel off so that we were burning off the heat exchanger. Okay, so we're just gonna look at it. We're just using max design outlet air temperatures, 185, okay? And it says right here, 3.5 inches water column, manifold pressure coming out of the gas valve. So all we can do is just check our temperature split from return to supply, make sure the discharge air is not getting above 185, trying not to get too close to the heat exchanger. Again, without a combustion analyzer, you know, there's not much more. But even with a combustion analyzer, there's not a whole lot you're gonna do. But if we did have it, we might maybe adjust past or something. But yeah, so we're just gonna watch it for a bit. We're currently wiring in a receptacle, and then just about finished up on this. We just gotta paint up some gas lines and stuff. All right, we painted the yellow gas line. painted the drain line black. Everything's looking good. So we're just wrapping the unit up, putting panels on it and stuff. Everything's good to go on this. This is all the customers now. They're going to be happy campers.
So this unit, we've done a lot of work on this. Over the last 3 years, we've put an evaporator in it. We've done a major leak repair at the compressor. We've changed the compressor oil. And most recently, I don't have video footage of it, but the reason why that really prompted the unit change out was that the unit was going off on low pressure because it had a completely restricted fixed orifice metering device. Of course, it happened right at the end of the summer when we had like a massive heat wave. So the unit, we were able to keep it running by having a mister on it, like with a water hose. And that's why in the video I was saying that the roof was all frozen, because we had a mister running on it just to keep the unit operating, right? It wasn't functioning very well. It wasn't efficient at all, but it got them through the remainder of the summer until we could get the unit replaced, which was right here. So this unit was done. There's a lot more equipment on top of this roof that needs to be replaced, but we have since changed 2 of their ACs. We've changed their bar AC and this one, both smaller tonnage ones, but they still have a few other ones. They still have a 7.5 ton, another 6 ton, and then they have a 10 ton, a 12 ton, and another 6 ton. So still got a lot of units that we need to get to and get replaced, but at least they got this one going. So when it comes to setting these things up, you know, I kind of glazed through the whole setting of the blower speed. The biggest thing is that our total external static pressure on the unit is too high, right? We have too high of external static, so therefore we can't set the blower speed as high as we want to without overloading the motor. So I did my best trying not to go too high over the static. Now, I realized that for the heating section, it says total external static should not be above 1 inch of total external static. Well, we're slightly past that. It's operating. We're right at 1.2 essentially. So that's about as good as I can get it until the customer lets me go in and do some duct renovations. Realistically, what we need to do is we clean the return air grill, not on video, but we cleaned it. And it made the static pressure a little bit better, but still not ideal. What needs to happen is they need a new return air grill that has some more surface area that allows more air through. So even with a clean return grill, we're still running really high static, and that's just, you know, a flaw of the equipment. If I remember right, they were running something like 0.53 on the supply, which is still kind of high too, but you know, you're really not going to change much about the supply because it's, you know, a long duct run, but we can, you know, improve the return. You know, if the customer would let me, like I tried to talk them into letting me just take the return air grill off, because essentially the return is just a drop up in the ceiling, right? And they have a totally exposed ceiling. So there's just a drop that comes down like 3 feet, and then there's a return air grill on it, and it's, you know, 15 feet in the air. And it's like, I tried telling them, the customer's not even going to know that you don't have a return air grill on there. Why not? Just take the return air grill off, increase the airflow through that unit. But for whatever reason, they didn't want me to do that. They wanted to leave the return air grill on there. So it is what it is. I can only do what the customer allows me to do. In a perfect world, I'd love to say, let me do this, let me do that. But, you know, it is what it is. So when we change out the units, sometimes we will change the duct detectors. In this situation, we had recently changed the duct detector about 2 years ago, so I don't see the need to do so. But we do install a new thermostat down in the office area, which is where all their thermostats, they're centrally located. I kind of glazed over the fact that this one has a remote zone sensor that's dropped in the return. You know, a lot of these restaurants, that's just how they've done it. So we just drop the zone sensor right back down into there. I do want to address the economizer wiring. So I said there's thermostat wiring coming up right next to the economizer, and it used to run through the economizer assembly itself. So it made it really hard to pull the economizer out to like clean the evaporator, do that kind of stuff. So that's why I mentioned that I actually ran the wiring, that thermostat wire that was passing through the economizer, actually ran it next to it by drilling a hole down in the bottom of the unit. I do that. I've done that a few times on these things, because in the middle of the summer when you're trying to clean an evaporator, it's a pain in the butt when there's wiring running through that economizer. So now just unplug the economizer, pull the whole assembly out, do what you need to do, and put it back together. So, you know, we did our best. We started the unit up. We got it operating. This was installed a couple months ago. I was just sitting on the footage basically. So we got the unit up and running. We did our best to set the gas pressure for the gas heating section. We set up the airflow as best as possible, and the unit was operating. Very importantly, though, is that metric that I showed using discharge pressure versus liquid pressure. So that's a good thing. A lot of times on these carrier units, they didn't have a liquid pressure port, so you would have to use discharge. On these newer ones, I do appreciate the fact that they actually have a port on both sides of the dryer. So you can actually check a pressure drop across the dryer, and it's a good metric to have just so that way we know what the pressure drop is across the condenser. So I mentioned that whatever the numbers were, I don't remember exactly, but we have discharge pressure and then we have liquid pressure. And so that's indicating that there is a pressure drop across the condenser. So keep that in mind when you work on one of the units that doesn't have a liquid pressure port and you're trying to check the system vitals and your subcooling's high. Well, sometimes on the fixed orifice metering device units, there could be like a 35, 36 PSI pressure drop across the condenser. So if you're reading discharge pressure, in reality, the liquid pressure, which is what you use for subcooling, is going to be 35 PSI lower on the fixed orifice metering device units. And whatever, I think it was similar on this unit. So that's just good stuff to pay attention to, obviously. And, that pressure drop, I would imagine, could go a little bit higher depending on the ambient temperature. Now that I think about that, is it possible as the ambient drives, the condensing temp goes up, your system pressures go up? I guess there's a possibility because it is it is a thermostatic expansion valve. So that pressure differential may or may not change. Interesting. That's an interesting. I'd love to see the numbers to see if it does change as the ambient temperature goes up and down. I mean, you're going to have a set pressure. You guys are seeing me think this through in my head. You are going to have a pressure differential that's not really adjustable across your distributor at the end of the expansion valve. But I'm intrigued. Does your pressure differential from discharge to liquid change as ambient temperatures change? I wonder if it does. I would imagine that you might see a little bit of a change. As the higher condensing temps, you might see a little bit more of a pressure differential across the condenser. I'm intrigued. Anyways, now that I'll think about that for the next couple hours and try to ponder that one. But hey, I really appreciate you making it to the end of the video as usual. If you're interested in supporting this channel, the easiest way to do so is do what you're doing right now. Watch this video from beginning to end. That really is the easiest way to support this channel. A couple other ways you can do so. If you want to support the channel financially via PayPal, it's like a one-time donation. You can choose the amount. There's a link in the show notes of this video. You can also donate via Patreon and YouTube channel memberships. So Patreon, you make a monthly commitment. It charges your credit card. If you go through YouTube channel memberships, basically the people that are YouTube channel members, it's just another way to do a monthly donation, essentially. One perk about YouTube channel memberships is that not all the time, but a good majority of the time, you'll actually get access to the videos a little bit earlier. I'm talking about like a day or something like that. If I get the videos done in time, I'll usually release them to the channel members. So you get, a couple hours, maybe a day early access to the video. And one of the cool things about having that is that people that are supporters, like recently I had a video 2 videos ago where there was a problem with the video and the channel supporters saw it and reached out to me ahead of time. I was like, hey, there's a problem with the video. I was able to pull the video down and still get it put back up in time for my normal release time. So that was just a cool perk. But yeah, if you're interested in Patreon or YouTube channel memberships, there's also links in the show notes of this video. Another great way to help support the channel is just by going to my website, hvacrvideos.com. We have merchandise available on my website, the normal flex fit, black underbill, breathable material hat, and then we have the other 2 hats that are right over there. You have the flat bill hat and the dad hat. Those are all available on my website, hvacrvideos.com. There's a couple shirts, sweatshirts, beanies, stickers. Now the sweatshirts and the t-shirts, those are all being phased out. So as soon as they're gone, they're gone. I'm not going to be restocking t-shirts or sweatshirts. The sweatshirts, we've basically closed them out to where we're not really making any money on them at all. I reduced them down to $25. I think they were at like 50, and I think I was making like $5 a sweater. But I just want to clear them out because we have a massive overstock. I basically way over ordered on the sweaters. About 4 years ago, I ordered a giant merch order, and it was like 7 pallets, like filled up my entire house and my garage forever. And they just don't sell. So they're really nice sweaters. But anyways, regardless, if you're interested in a sweater, they're like $25 for anybody in the United States with free shipping. I do ship to Canada too, but they're, you know, the price is a little bit higher. Plus Canada, I think their postal service is still on strike at the moment. So there's no shipping to Canada at the moment unless you do UPS or FedEx. Anyways, going off on a tangent, HVACRvideos.com is my website address. Check it out. Lots of great stuff on there. Last but not least, if you are interested in purchasing any tools, you saw that I was using the Fieldpiece SC480 meter in this video. And I was also using the JobLink probes, which you really didn't see, but you saw it when I was using the Measure Quick app. I was using the JobLink probes to get all the pressures and everything. I picked all that stuff up over at TrueTechTools.com. If you're interested in purchasing any tools, you can go over to TrueTechTools.com. I have an affiliate code with them. So if you use my affiliate code, you get a discount at checkout, and then I get a small commission from that. There's a few things that discount doesn't apply to, but for the most part, you get a discount on majority of their items, and then I get a small commission. So it's another great way to help support the channel. Win-win, doesn't cost you anything extra. You get some tools out of it, and then I get that small commission. So again, TrueTechTools.com, my offer code BIGPICTURE, one word, at checkout. Thanks so much for making it to the end. I really do appreciate you, and we will catch you on the next one.